Hi, I'm Dr. Mark Plett and I teach the Practical Software Defined Radio class for ATI courses. The purpose of this course is to provide fundamental skills in software defined radio to help the novice be more effective with some of the readily available, low-cost, open-source software defined radio technologies. In this course, we'll focus on the GNU radio framework and some low-cost hardware receivers and other free open-source software that can be used to rapidly develop effective software-defined radio applications. In the class, we provide software that contains a complete development environment with GNU radio and all the software you need to be successful with SDR. We also provide an RTL dongle, so you have a hardware receiver that lets you receive real-world signals in the class. You take this home with you so you can continue your learning on your own. The evolution of the learning in the class begins the 3-day class on day 1, where we lay a foundation of signal processing and software development. Having built a foundation of these 2 core skills, we are then able to move into the 2nd and 3rd day, where we apply that to software-defined radio. On the 2nd day, we focus on the basics of GNU radio and the utility in this advanced open source framework. And then on the 3rd day, we bring all our skills together in a real-world application where we look at how do we write a software-defined radio to demodulate my home ceiling fan remote. So while it seems on the surface fairly trivial, there's actually an excellent progression from the simple software-defined radio that we implement on the RTL dongle for doing an FM radio receiver to the digital signal produced by this remote. So by the end of the class, you've developed a set of skills to both master the GNU radio software-defined radio framework as well as software development in the Linux operating system, to where you'll feel confident taking on any real-world SDR application. Hi, I'm Dr. Mark Plett and I teach the Practical Software-Defined Radio course for ATI courses. And I would like to tell you a little bit about the material we cover in the 3 days of the Practical SDR course. In the first day of Practical Software-Defined Radio, we cover some foundational skills related to communication systems, signal processing, and software development. We begin with the most basic elements of what we need in our communication system to send a message over a radio link, and we build up from there the signal processing and mathematics that we require to implement a software-defined radio. The last topics we cover in the first day is how we develop software in the Linux operating system. This is a very practical skill that is required for success with developing software-defined radio in the GNU radio framework, which we use in the following 2 days. On the 2nd day of the course, we dive into how to develop software-defined radio using the GNU radio framework. This is a very powerful open source framework that's seen a lot of popular adoption, and so we utilize it in this course. The 2nd day of the course focuses on, in the beginning, how do we use the existing signal processing in the GNU radio framework to develop applications that leverage the existing capabilities therein. Then in the afternoon, we extend those capabilities by writing our own custom signal processing blocks that we build, compile, and then integrate into the GNU radio framework so that we can extend and further advance the software-defined radio capabilities we can develop in that framework. On the 3rd day, we move into some advanced topics and we look at a practical application of the software-defined radio skills we learned in the first 2 days. We take on a practical application of those skills in how to develop a SDR modem for the reception of a digital ceiling fan remote control. While on the surface it seems like a fairly simple exercise, it actually provides us the opportunity to leverage all the skills we developed in the previous 2 days to develop a real-world software-defined radio application that uses the GNU radio framework as well as custom signal processing that we develop, compile, and build into the application. On the end of the 3rd day, we look into the advanced features of GNU radio as well as some of the capabilities that are available in other free and open source software packages such as Red Hawk, GR Mode S, and GQRX. By investigating some of the capabilities available in these open source projects, we see how we can continue our learning on our own and how we can advance ourselves in software-defined radio, leveraging the advances going on in the open source community.